Okay, so here are our presenters. I believe Doug was not able to make it tonight, but he was a participant in the book. So thank you, Doug. So we'll start with Kateri Thunder. And I'm going to be quick so I can give the time back to our panelists. Kateri is a Virginia-based educational consultant and coach with specialties in early childhood education and math. John Almarode is a professor of education at James Madison University, and he began his career in the math and science classroom. Michelle Shin is Southern California-based educational consultant specializing in math and leadership. And Nancy Frey is a professor of education at San Diego State University and a leader of health sciences high and middle college. And with that, I'll turn it over to them.
Hello, everyone, and welcome. I see a lot of folks kind of entering and interacting with us in the chat. That's a wonderful sign as we begin our session. My name is Michelle Shin. I have the pleasure of starting us off and talking about really opening up the topic for today. And the topic for today is activating classroom discourse. And as we heard from Jessica, we hope that you'll stick around at the end because this topic about discourse and math talks is rooted in module 8. So if you just want to note that where I might find that in the book, it's in module 8 there. And of course, you know our style, you know what we like to do. We like to start with our learning intention and success criteria. So we hope that by the end of our session, that you will agree that you learned ways to engage learners via math talks. And you will know that we've learned this if you can do these 4 things. The first is to explain the importance of mathematical discourse for that deep mathematical understanding. The second is to identify the variety of formats for math talks, because there's some choice there. Third is to describe ways to scaffold speaking, listening, reading and writing, and in the math talk structure. And then last but not least, to examine strategies for self-evaluation through math talks. We know as math folks that input does not always equal output, right? So similarly, teaching does not equal learning. And so when we model discourse as the sage on the stage, it doesn't always translate to our students' ability to engage in discourse themselves. So what I appreciate now being a more seasoned educator, but as a young math teacher, I was convinced that no one was further from understanding what it was like to be a math teacher than an ELA teacher, than an English teacher. You don't understand what it's like, but I'm happy to say that the longer I was in education, I looked at literacy a little bit differently. So when I think of discourse in math, I think of the ways that math talk can help to scaffold comprehensively in these 4 areas, right? Because our learners need to know how to speak, read, listen, and write like a mathematician. So I do appreciate my ELA colleagues for sticking with me and impressing upon me that literacy matters in all content areas. But why math talks? Why does that matter? What impact does it have? Because some of us might be thinking, I'm pressed for time. I need to get through the content. How do I manage my time so we can do this thing called math talks? And like most big rocks or priorities, it's not about managing time, it's about creating it. So I would like for us, since I've been talking for a little bit, to turn it over to you all in the chat for a moment. Why is it important to create time for students to speak, listen, read, and write? What do you think the impact is? And I'll share a couple of reasons through research, but what do you think a couple of those reasons are? What's the impact? If I could turn it over to you all to do maybe like a 1 minute, 90-second kind of brainstorm in the chat. Why do you think that matters? Oh, these are good ones. I'm seeing some themes already. Loving the engagement, loving the patterns, the emerging patterns here. And in about 10 more seconds, because I gave you about 60 seconds to 90 seconds, I'm going to give you a couple of the impact according to research. All valid, all correct. Here we go. Starting with impact number 1. Classroom discourse. We know that according to the visible learning research, that it has this ability for students to, an opportunity for students to discourse in class, has an effect size of 0.82. So if that's not convincing enough for you, let me move on to reason number 2, or impact number 2. Students, when they engage in math talks, they are held responsible for justifying their reasoning. And so that then leads to an increase in mathematical knowledge and understanding. I hope that as I'm going through this, by the way, that you're all self-assessing. Oh yeah, I said that. Oh yeah, that's what I, fantastic. Let's continue on to reason number 3, according to the research. They overcome difficulties through discussion. We talk about in math class, we need to give them grit. They need some grit, some perseverance. Well, they get to do that and practice that through their voice and using strategies for that problem-solving piece. Reason 4, impact 4. They make sense of mathematics by concentrating on the reason. So have you ever been so sure of something and you've been thinking about something for hours and then you say it out loud to someone, you go, well, that didn't really make sense as much as I thought it did in my brain. So Math Talks helps to, edit that, right? Which leads us to the next impact, which is impact 5, to clarify their thinking and learning from others. I think that's pretty self-explanatory. So which then leads us to impact number 6, according to the research, developing metacognition. And I saw that word specifically show up in the chat. So it develops metacognition, right? What they know and what they don't know. And they were able to reevaluate that in that collaborative space with Math Talks in a respectful manner. We know what we can never have too much practice in that. The next, I don't know if I am allowed to have a favorite reasons, but this is the 7th one. Of the 7th one, if I had to choose a favorite reason, it would be this: to discover misunderstandings, deepen meaning, boost memory, and develop language and social skills. I think this is really like the doozy, right? This is the all-encompassing, save the best for last impact number 7. Looking at these 2 frameworks on the screen, you'll see either ways that the 7 impacts I went over either make its way explicitly or implicitly, that they're embedded in the NCTM standards as well as the Common Core Math standards. So definitely a good investment of our time. Well, great, Michelle, you've been talking about the why. Can we just talk about the what for a moment? Like, what are Math Talks? I'm glad you asked, because we want to orient our thinking. We want to orient our language so that we have a common understanding of what that is. So as you see on the screen, Math Talks are respectful, engaged math conversations for all learners, right? Ultimately, learning is a social construct. It's great that you can do math on your own, but you can do better together. The second part about the Math Talks definition is it's daily, rigorous, meaningful mathematical discussions. So that way they can construct their knowledge, and that will support all learners. There are 4 elements of Math Talks, and you'll see that there's a spectrum here. On the left, there's the teacher-oriented, more like answer-focused, traditional maybe way that we've seen math, but over the course of our math education, when we know better, we do better. So you'll see on the right side of the spectrum, you've got the learner-driven, learner and reasoning focus. So I love that, because each element that's listed on the screen can take place, can find its place on the spectrum. So we hope that if it starts on the left, that Math Talks will help move those elements to the right. So for example, for questioning, moving from a teacher being the questioner towards both students and teachers questioning. If we look at explaining math thinking, again, think alouds are great. When the teacher is the one focused on the answer and the teacher is the sage on the stage, is great, but not at the expense of students having opportunity to explain and articulate their own math ideas. The third the source of mathematical ideas and that kind of, so what does that mean? So the source is not just the teacher, they know all the answers, but this is a collective effort, right? All together, that it shifts and there's an influence that shifts in the direction of the learning. And then lastly, the responsibility of learning. So students increasingly take on that responsibility, and they can evaluate themselves as well as others. So in conclusion, you can see how the classroom community through Math Talks, and that's a strategy that can grow. And students can be the central or leading roles of the math discourse or the math classroom. I have the pleasure of handing things over to Dr. Kateri Thunder. Kateri.
Oh my goodness. Thanks, Michelle. Guys, I love how active the chat is. You all are amazing. So many questions, so many things to think about, right? To wonder about when we think about supporting both educators and students in talking about math, and also math, everything, right? So we had to narrow to, let's just think about math discourse. And then even from there, how could we kind of narrow even a little bit further to make sure that you feel like, yeah, I get some ideas from this, right? I kind of get what is a math talk and how could we engage in this? And I think what Michelle just shared, the shift, right? Trying to move from teacher-oriented and answer-focused math talks to learner-driven, learner reasoning focused math talks is a space that we can sit in together as K-12 educators and think about, what does this mean for how we engage in the math talks and how we support teachers to feel safe having learners be the leaders, right? How do you feel confident, right? Because often in math, we feel like we've got to have all of it, right? But in a math talk, we can open that up so that learners have it. They own it. All right, so here's what we're going to do. We're going to try a few. Now, listen, there are so many. This is just a teeny tiny list of some possible math talks, and they are everywhere. There are so many amazing resources. You should never feel like you have to make something from scratch. And we are going to try out 3. Now, it's going to be a little bit strange. We were laughing that we were going to do some work with math talks, but we're actually not going to talk out loud with each other. But that's okay, because we're going to still feel how this works and think about that metacognitive space, how you can practice trying some words out, right? That thinking. And you might know a word in one space or in one language, and then be not quite sure how to use it in this space. And this is great because this is our chance to practice it. Nancy put the little a joke in there about derivations in math, and we were laughing before we got on about how there's derivations in English and there's derivations in math, right? And what do they each mean? Is there a relationship there? And how could we use that word? So it's okay to try out a word that you think you know, but you're not sure about today. All right, so our first one to try, ready, y'all? It's debattle. It's a little mix between a debate and a battle, made up just a mix-up in conversation with students, and here came the word debattle. So here's our goals. Each time I'm going to share with you what would be the goals, what were the goals for the class when they tried this, and how did they do some self-evaluation, and we're going to try it out together. So for this class, this is a middle school class. They're learning to build on what they already know about odd and even numbers to make a conjecture and to share that unfinished rough draft thinking about conjectures and initial evidence. And why are they doing this? So they can make connections between their prior knowledge and trying to make sense of something new, right? And how will they know they've learned it? When they can propose and attempt to defend a generalizable statement, to decide if any number is odd or even, right? So we're sitting in this space of I'm going to share an idea. We're going to see, I'm going to have a conjecture. I'm going to have some evidence, but I'm going to constantly be coming back to revise my thinking. All right, so I'm going to share with you some supports along the way, some scaffolds, some language scaffolds. So how we're going to try this is with a poll. You're going to say your thoughts about something, and then you're going to defend it in the chat, okay? So you're going to have a conjecture in the poll and then share your defense or your evidence in the chat. You can put your initial thought in the chat, and then you can reply to each other. and you can use these language frames to support you. Now, also, know that there will be plenty of laughter in this, because coming back from COVID, this was a middle school class where there was not much talking, and the teacher was trying really hard to figure out how to get these tweens, right, and young teenagers to start talking and to talk about math and disagree with each other in those respectful ways. All right, so you ready for the first poll? It's riveting stuff and very important for us to decide. Is a hot dog a sandwich, a taco, neither, or both? All right, so you've got your poll. Click which one you believe it is. And then once you've said which one it is, will you please put in the chat your evidence or your defense, your unfinished thinking, your initial thinking about why? Oh, we got 25 seconds. Good. Oh, I see some people thinking about it. I appreciate that you could find another possible answer. That's excellent. All right, I'm going to end the poll so you all can see some responses. All right, so we've got a lot of people who think, oh, that a hot dog. I'm sorry, it should have said sandwich. That's so funny, you all. My mistake. Okay, a taco, neither or both. That is so funny. Oh, you all. Okay, so which one did you think? And I see a lot of responses. I see some people using those language frames. It's neither. A sandwich requires 2 pieces of flatbread, and a taco needs shells or tortillas. Nice, Trisha. Thank you. Oh, they're all sandwiches, toppings surrounded by carbs. Delicious. Okay, now, if you have a response and you're thinking, okay, remember one of our goals was to have some refined thinking, right? To take a thought and kind of think, maybe I could rethink that a little bit differently. If you have changed your mind or you see how a hot dog could be something else, will you put that in the chat, right? So kind of a used to think, now I think moment. Yeah. I see some people who thought it was 2 things, right? So maybe they're leaning one way or the other. I love it. Thanks, Lisa. Okay, Denise, I see what you're thinking.
They're
Oh,
really
I like
out. They are.
I know.
This is
I
incredible.
love these.
And so when the person that said it's a hot dog because it's a hot dog, is that a tautology? That's a mathematical tautology, right?
Nice. Yeah.
It's also a poetic tautology too.
Oh,
Well done, Dr.
look at
Almarode.
us.
Well done.
I love this. Now listen, guys, now you got the question from Angie. John, what is a tautology?
I have no idea. Kateri, do you want to?
You know it when you see it?
I know when I see it.
Thank you, Julie. Sorry, I can't stop laughing. Yeah, it's a circular statement. So something is something because it's something, right? Yep, it's
Right.
true because it's true. Lovely. Yep, a hot dog is a hot dog because it's a hot dog because it's called a hot dog, and that's where we are. Nancy, sorry, go ahead.
It's saying the same thing twice with different words.
Beautiful. All right, y'all. So I'm hoping that you feel like, yeah, I can share some opinions. Okay. So now remember, our goals actually weren't around identifying this hot dog. It's around the number 0. So here we go. We're going to be thinking about, is 0 even, odd, neither, or both? So go ahead and pop your response into the poll. Which one is it? Even, odd, neither, or both? Ooh, and when you have your response, post it in the poll, put your evidence or your reasoning into the chat. People are really thinking hard about this one, guys. I have a feeling there's some people Googling this answer. I love it. I love it. Because look, we've got half of the people responding to the poll. All right, guys. Time for your final decision. Final answer is I'm going to end the poll now. All right, check it out. Here's where we are. Most people said neither, some said even, and a few people said odd or both. And I see a lot of reasoning in here, a lot of reasoning in the chat. Yeah. Okay, so now is your spot where you could say, respond to someone's thought or see if you have a revision for your thought, right? I know there were some people who were thinking hard about this, and maybe they were thinking, Kateri, why did you give us this option? Even, odd, neither, or both, right? I've had many people wonder, why is this even a point of conversation? And you know, what's really fun is that this is an actual mathematical debate, right? Not all 4 answers, right, are mathematically debated, but part of these are, right? Is it even or is it not even? Is it not neither, nothing? It's a special kind of number. And mathematicians will talk about how, well, it depends on how you're defining even to help you decide if 0 is even or neither, if it's a unique number. You should totally check it out because I love that we think math is so black and white and there's absolutely a right and a wrong answer. And in the end, where we go as mathematicians is there's so much gray and it's up for debate and brilliance and beauty. So we're going to come back to our goals for this math talk, this debattle, and check in. Where would you say you are in proposing and attempting to defend a statement of a number being odd or even? Where do you feel like you are in that? Do you think you're green, doing great, going and ready to continue on? Yellow, you have a question, but you can continue on? Or red, you're stuck and you can't go any further? Where would you say you are? Love it. Lots of greens, lots of yellows. So this is a space where mathematically, I think it's great if we can be sometimes in a yellow space, right? To say like, I'm going to need to think about that a little more because that can dive further into our work, right? It can help drive us forward to want to know more, to want us to understand more about even and oddness, about how to make a generalizable statement, about how to make a conjecture. So this is that space when we think about the 4 elements of a math talk, right? It may start out in a space where I'm the person as the teacher coming up with this question, right? And I purposely started with something that was, fun and hilarious. And of course, all of us could have an opinion about it, right? And then shifted into something mathematical. But over time, by trying these out with our kids and even pairing something that is not risky, right? Low risk, with something that is more mathematical language, then we can engage more kids and help them to engage in the conjecture and the debate and the math talk. And then we can pass it over to them, right? So we can even have kids suggest things to debattle, right? I had a kid say, let's debate if ketchup is a smoothie or a sauce. And I was like, smoothie, right? Yeah, I know. That was my reaction too. Like, well, I don't know. Olivia shared about ravioli. Is it a Pop-Tart, right? So interesting that you can just come up with these brilliant things to debate. And the point is not necessarily getting to an exact correct answer, but mathematicians give conjectures, then they defend it. And then based off of this talk, this back and forth debate, they refine their conjecture. This is from a 4th grade class where over time, they came up with math questions that they just couldn't answer, right? We don't have time to get to everything. And so this class came up with these questions that they wanted to engage in. They wanted to either debate or discuss. And that's another space where we can become more learner driven, more learner focused, right? Where they're sharing their reasoning and they're even the people coming up with the questions. They're even the people where we've held on, hey, these are some questions. Okay, let's come back to them. Right? Let's engage in this together. All right, I have one more notice, wonder, estimate. Ready? Okay, so here is our goal. Learning to use what I know, see, connect, ask to make a reasonable estimate. I'm learning to use this language of estimation or approximation, and I'm learning the power of making a mistake when I estimate so that my next estimate can be more reasonable. Now, why is this, right? And we don't often say this for kids, but it's so that when I can't actually get to an exact answer, right? Or it's not necessary. I can actually make a reasonable estimate. And the entire process of estimating is about providing a conjecture and then revising it. So we'll know we're successful when we can describe an estimate and use some phrases: about, between, close to, less than, more than. And I'm going to show those again to support your talk. And then when you can make an estimate and then refine it. So here's how we're going to do this. I'm going to ask us to do a little waterfall. I'm going to show you an image and ask you, what is your estimate for the diameter of a propeller? And I'm going to show you some words and ask you to finish with a because. So you're going to share your type it in, your estimate, and then because. And then when I say go, we'll all click together so we can see each other's estimates. And then we'll move on from there. Okay? So here it comes. What is the diameter of the propeller? Take a good look. Remember, our goal is to use those phrases. And then make sure to add that because. Okay, so go ahead and type in what's your estimate and make sure you have a because. All right, I'm going to count it down, and then we're going to click to send it to everybody for a waterfall. You ready? All right, go. Hit enter. Let's see that waterfall. Wow, look at all those estimates. Whew. Okay, so take a moment, because remember, one of our goals is to be able to make an estimate and then refine our estimate after talking, listening, seeing, and in this case, reading appears reasoning. Okay, so find a few to read. Read a couple, and then think about, how would you refine your estimate? How might you change what you initially thought? Would it confirm something that you already thought? Will it help you get closer? Right? Does it adjust your between or your about, or what it has to be more than or less than or close to? And then get ready to type your new refined estimate. Okay, so you're typing your new refined estimate. We've got lots of really amazing reasoning, you guys. Whew. Put your reason why. What helped you to refine? What helped you to change your estimate? And in just a moment, we're going to do a waterfall again for our final revisions. Okay, so go ahead and type in what's your new estimate, what's your refined estimate, and why. And then get ready to send it. Okay, send. Guys, it's really phenomenal to look to see what influenced your revisions. Some people are saying that they looked closer at the image after seeing how people were using the image, right? Some people were saying things about the relationship between wingspan and height, that maybe you didn't know that relationship and now you do, so that helps you. Or maybe you didn't think about, oh, there's an average, right? A typical height of men, and you could use that information. There's some people who are thinking in feet or in inches, right? So you're thinking in different units. All of that is coming up by checking in with each other and sharing our estimates. We're going to get closer and closer to saying, okay, I don't need to know the exact diameter, right? I just need to know about how big it is, about how big that diameter is. Thank you, Martha. Just double that radius, guys. You got it. That's lovely. All right, so check in, right? Here we are. Where would you say you are? This is a different way to evaluate yourself. Would you say that you are at a 1? You're just learning about this estimating thing. Would you say you're almost there? You need a little bit more practice? Would you say you own it? You could do this independently. You'd like to just, do as many of these estimation images as possible. Or 4, you're a pro and you're going to start creating your own. I love it. Yes, you use estimation 180. Listen, guys, we don't have to make any of this. It all exists. It's so phenomenal, the resources that are out there. But what we do have to do is think about how we're going to engage kids and talk, right? How we're going to help them engage in some self-evaluation and empower them to use the talk to learn, right? To use some of that unrefined, right? Just rough draft thinking. Awesome. So another space where we can move. So in this one, I shared with you this image, right? But one of my favorite things is after doing this, my kids started sending me images, right, to use. They took over this estimation math talk and said, I want to lead it. I got one. Here's one. So here's one of the images that someone brought in from baking, right? And you estimate how many there are. And I had this moment, you all, do you remember going to like fairs and carnivals where there'd be a jar and you had to estimate how many were in that jar? And I was always wildly inaccurate and could not figure out how people got so close. And after engaging with my students with this, I was like, oh, I think I've got some strategies. You got to know some things about layers, right? You got to know some things about width and height and estimating one thing and using that as a reference to go around. I learned so much from it. One of my favorite debates that we had was when we got an image of an icicle to estimate how many or how long is this icicle. And we realized that to really estimate, you have to have a reference point, which is a huge place, right? Huge place with estimating. So here was the image that we had. Well, you can't really tell, right? There's no reference to help us figure this out. And so then with this reference point, we can really estimate that icicle. That's a big icicle. Thank you, Iceland. Yeah. So it was a whole other space to help us when learners were bringing the images and leading the conversations to figure out what are the parts of estimation that we're not clear about? What are some things that we need to highlight? What are some of those misconceptions, right? Or just conceptions about estimation that I'll just come up with an answer. But a reference point really helps, doesn't it? Yeah, Lorraine, isn't that crazy? All right, y'all, are you ready for one more? I think we have time for one more. John, Nancy, you cool if we do one more? Okay, because listen.
Absolutely. Which one are you going to do? It depends on which one you're going to do.
I'm going to do a little data science because, data science is big and empowering. Is that all right?
Sure. And then if you can just tell us about two truths and a lie, because I'm
definitely.
That one, I don't play in environments that are appropriate for children. So it'd be nice to see how you could use it in a classroom. So make sure you definitely at least highlight that one. But yeah, definitely do data science.
Let's do it. Okay, we'll do data science. We'll do a little two truths and a lie, and then I'll pass it over. All right, so a little slow reveal data. Okay, numberless graphs, data science, so important. Okay, so here we are. This is a lovely one for young kids, right? I've done this with second graders, first graders, right? Definitely even some kindergartners and third graders. So I'm learning to understand this relationship between the parts and the whole graph in a bar graph, because there's so many pieces and parts that make that graph readable. I'm learning to identify and describe those parts and revising my thinking through conversation. And why do I want to do this? So I can interpret data represented on a bar graph. How many times have we been presented with data and we have to make sense of it, right? What does this mean for me? So I'll know I've learned it when I can describe a bar graph using words like x-axis, y-axis, greater than, less than, typical, scale, key, all those words. And I can explain how my thinking changed. All right, so in a slow reveal graph or a numberless graph, you show something, show part of a graph with less than all the information, and you just share what you notice or wonder. Okay, so here's the first one. Pop into the graph. What do you notice? What do you wonder? Oh, Nancy, I love it. A day without numbers. Whoa. There has to be a book written about that, right? There must be a read aloud, or there should be. Yeah, why are the first two the same, Elizabeth? Gradually increasing trend. Nice. See that word? Trend. The bars increase in height. Nice. Yeah. Ooh, things could be compared. Nice. We're looking at heights of bars. You see how all this language is coming up as we're just describing bars, honestly, little green bars. What do they even mean? Okay, you ready for the next part? Ugh, do they represent 5 days a week? This totally happens. We start to think about, well, what could it be? What could be important that there's 5? There's 5 of something being compared, being counted in some way with some intervals. What is this? Okay, ready? What did we just learn? How does it change your thinking? And yeah, go ahead and laugh because the best part of math is when we're laughing. What do you think this graph might be about and why? Popular class pets. Where are we living? I love that idea. Number of offspring. Excellent. I don't know if the US is keeping that average going, but maybe. Yeah. Number of mammals in a litter. Yep. Favorite mammal. Love it. Yep. That part on that left side might be helpful, right? To know what are those intervals over there. Yeah. Milk consumption. Okay, here it comes. Now you see the numbers. How does that change your thinking? How does that change your thinking? Ooh, teacher level of frustration. All right, so we've got number of teeth, age, popular TikTok videos. Yeah. Yeah, born in the spring. Yeah, look at that. All right, ready? One more reveal. How many are living in the area? Interesting. Okay, so here it is. It's the number of baby teeth per mammal. And there's the number of teeth. It's a baby teeth, though, right? The number of baby teeth. So what new information did we just learn? Well, mammals have 2 sets of teeth, baby teeth from infancy, right? Sometimes milk teeth, sometimes deciduous teeth, and then they get permanent teeth later after the baby teeth fall out. Yeah, how could it be different if you compared baby mammals with adult mammals? I love it. Ferrets do have a lot of baby teeth. Maybe not your best, maybe not your best home pet, right? Okay, now here's one little bit that's been added, a key. What do you think those colors mean? We've got blue on the cow, we've got yellow on the human, and we've got pink on the cat and the dog and the ferret. Yeah, I love it, Emily, right? We're just going to end up connecting. This is like such a great source of integration, a space where we can actually, show how things connect. That's one of the beautiful things about data science is that it's just ripe for integration. Love it. Ah, Megan, you got it. Da, da, da. Herbivore, omnivore, and carnivore. So we can do like a little check-in and make sure do we know what it means to be an herbivore, an omnivore, and a carnivore? Why would mammals would have different number of teeth depending on what type of eater they are, right? You guys are awesome. So slow reveal graphs or numberless graphs, amazing. Okay, so another way you could check in to see how you're doing, right, is to see where were you doing a really great job? What is your glow for being able to describe a bar graph using any of these words? X-axis, Y-axis, greater than, less than, typical, scale, key. You could even pop back and look in our chat to see, did you use any of those words, right? Is that like a star moment for you? Where did you see yourself explain how your thinking changed, right? Is this a moment that you're like, oh yeah, I see, I changed my thinking here, and I explained why? Where's an opportunity for growth? And then we can always give each other feedback, right? Because we've been with a partner, but we can support each other in that conversation by saying, hey, you were talking with a partner, maybe you could give them a little bit of a glow or a grow. And you could say, hey, you know what? I noticed that some people changed their thinking 4 times each time that I showed part of the graph and explained why. And I saw so many people thinking about scale. And then how would you receive that? Well, I appreciate you noticing that, right? I appreciate you noticing that I changed my thinking and could explain it. That was one of my goals, was to be able to explain that change. This is amazing. I absolutely suggest that you try diving into this as a part of Math Talks and then try to shift that ownership. Who's asking the questions, right? What are you wondering? What are you noticing? What are you learning? How are you explaining the math idea? Who's the source of the math idea? Who is responsible for actually making sense of this graph? And then as you go into the world with your students and see more data, they're going to come to you with ideas, right? This is one of my favorites. I had kids coming to me with the Steve Jenkins books, Animals by the Number, and saying, let's make some slow reveal ones. Let's slow reveal it. And they would cover it with Post-its and then pull the Post-its away to reveal slowly what they knew about the graph. And they would lead that conversation. It's really phenomenal to watch. All right, last one. Ready? The 2 truths and a lie. And John wants the G version of this. Okay. So here it is, 2 truths and a lie. There are so many that are brilliant and beautiful. So this one is around making sense of the volume of an object, trying to connect the volume of an object represented by an image and its formula, right? And how do we remember, how do we make sense of what's the volume of an object, different 3-dimensional shapes. So here are your choices. There are 2. This one is 2 that are 2 that are wrong and 1 that is right, right? So this one's 2 lies and a truth. So you would look and see which one do you think is true and which one is not. Does anyone have a thought about that? Has anyone found one that they think is right? Or one that they think is wrong? Nice. So you can already see, right? People are thinking about like, which one's correct? Why? Which one is wrong? Why? Which is, honestly, this is a great reasoning strategy in general when you're given multiple choices to say like, I can find the thing that isn't true, right? And here's why. And by deduction, ooh, great math word, you can come down to, well, then this one must be right. Or you're looking for the one that is right. And I see some people who are doing some calculating, right? They're really looking at that equation and figuring out, is it really equal? Are the names of things correct, right? Do they have the radius labeled and are they using radius correctly in that equation, or did they use the diameter by accident, right? So all of those are ways that you could analyze this and then bring all that mathematical knowledge to the surface. So you guys are phenomenal. I'm so glad that we got to try as many as we did. Thanks for bringing it up, John. And I encourage you to never feel like you have to be the creator of the initial one. Check out all the different ones that exist, but then think about how can you pass this off to your kids? How can you have them be the leaders of this work? How can they be the people that find the examples that are meaningful to them and that will bring up the conversation and the vocabulary that is important to them and needed by them to learn? Well, John, Nancy, I've left you the teensiest bit of time to think about some scaffolds. But hopefully you experience some scaffolds as we continued our work.
Yeah, and Nancy, you and I get to close it out. But if you don't mind, I want to give a task to the participants first. You saw several examples of scaffolds. And Nancy and I are going to close out by talking about scaffolding, because if we don't scaffold, then our think, pair, share becomes a think, pair, stare. And so how do we make sure that learners are scaffolded into it? I want you to take a moment in the chat box and share with Nancy and I, where do you think Kateri and Michelle scaffolded our thinking before we dove into the math? Just share some ideas. Put those in the chat. Mm-hmm. Excellent. And so in the brief time, and keep at them, in the brief time that we have together, Nancy, let's go through, let's go through some scaffolds. What is it that could be in place to help those learners? Now, Elizabeth, you brought this up, and I'm so grateful that you did. What about multilingual learners? Some of you asked, well, can we do this with high school? And the answer is yes, of course. All of it requires scaffolding. And to set the stage, I'm reading Adam Grant's new book on hidden potential. He's at the Wharton School. And what I find fascinating is in the prologue, within the first couple of pages, this is what he says. If you build it, they will climb. And what he's talking about is scaffolding. And so, although if you're an elementary teacher, you know exactly that means something completely different. But if you build it, they will climb. And so the argument is, what if you think my students won't engage in math talks? My students won't do this. My students won't do that. Well, let's talk about scaffolding, and there are 4 of them. There are 4 types of scaffolds or categories of scaffolds, and you see those on the screen. So Nancy, tell us a little bit about front-end scaffolds.
Well, front-end scaffolds, I like to think are those just in case kinds of scaffolds. In other words, anticipating, being reflective about who your learners are. What are those just in case kinds of scaffolds that I want to make sure are available for students to be able to use, to be able to get that toehold right from the very beginning. And as many people identified in the chat, those learning intentions and success criteria are a great just in case kind of a scaffold. And Kateri, you certainly helped all of us in being able to do so because we knew what the purpose was kind of going in. But some of those other front end scaffolds are things like being able to do a little bit of pre-assessment, a little initial assessment. What do they know? What do they not know? Right? Asking them to be able to speculate, for example, so that you can get a sense of their thinking. Certainly, front-end scaffolds include at times kind of that acceleration model. What do I believe that these students need who are perhaps currently not at those expected levels? What do they need to be able to access this grade level text? I'm going to make sure that that happens through some pre-teaching. Or even like, for example, when we've got rich mathematical tasks, for example, and there's a lot of reading, being able to chunk that out so that they're taking those bite-sized pieces of that information to figure out what that task is.
And if just in case scaffolds are front-end scaffolds, I think, Nancy, distributed scaffolds are best described as just in time. That moment that they start to shift from focus to frustration, from productive struggle to unproductive struggle. And you watched Kateri and Michelle do that through our entire experience, where they would add in things. Michelle distributively scaffold. I'm not sure if that's a real word. When she was giving us the 7 big ideas, she helped us start to make sense of that. Kateri provided words for us to use when we were talking about more than, less than. She gave us examples to support our thinking. Those distributed scaffolds help along the way. I often put this in the category of what Carol Ann Tomlinson referred to as differentiation of process. What manipulatives and strategies do you put in place for learners as they're into it? What manipulatives are going to be available to that learner when it comes to finding the volume of a cylinder? And so that they can successfully navigate 2 truths and a lie, or 2 lies and a truth. What supports am I going to put in place that continues to give them access? Kateri constantly posed questions. Nancy continuously put questions into the chat box to help kind of push our thinking forward. If front-end scaffolds are just in case, distributed scaffolds are just in time. Just in time.
So let's talk about peer scaffolds, because John, I think you and I are aligned on this. This is an underutilized scaffold. And for everybody out there who's feeling a little bit tired right now, remember that it's not one teacher and 35 kids. It's 36 teachers potentially, but you have to be able to activate that. And there is good, solid research on both the use of class-wide peer tutoring as well as those peer-assisted learning strategies. I'll talk about one that is a favorite of mine. Joseph Asoff, one of our colleagues, has what he calls Mastery Mondays in his high school mathematics classroom. Students come to class prepared with a problem set that vexed them from last week's homework, and the students regroup around what was that problem set that gave them difficulty, and together they work it out. Now, Joseph's there doing some of that circulating and assisting as needed, providing some of those distributed scaffolds, but it's actually the kids who are working out what that problem is.
And you know what I found fascinating, Nancy, about our time together well, for some of you this morning, this afternoon, this evening, wherever you are globally, is that the peer scaffolds happen naturally because of Kateri and Michelle's brilliant front end scaffolding. And so you saw folks putting in even numbers are equal to 2n, odd numbers 2n minus 1. Folks were putting out the radius is 3, not 6. And so there were scaffolds being put in place. And so if at any point you felt a bit overwhelmed by the two truths and a lie, if you felt overwhelmed by the data science, there was immediate help from peers in the chat box that gave us the information we needed to step up to the plate, that allowed us to have access and opportunity to that learning. So here's the last one. And this one, I have to tell you, Nancy, I struggle with this one because this one often I need scaffolding on, because there's a fine line between a back-end scaffold and a front-end scaffold for the next unit. Here's the example I try to put into my head with this. It's often where the learning, it's at the end, of course, but it's where the learning is finished at the moment. And so what kind of scaffolds in place do we need to do to correct those very isolated, narrow misconceptions or errors, but at the same time provide feedback that goes just beyond those expectations, right? And maybe lock in a few things, but not go back and reteach the whole unit, the whole experience, but building those scaffolds. Or what if it's study skill related? For example, and he would probably be horrified if he knew I was about to tell you this story, but I'm helping my son prepare for an end of course test in Virginia. The end of course tests are occurring right now, as they are for many of you. And one of the things I noticed about Jackson is it's not so much the content, but it's the way the question is framed. And so how do we put in some back-end scaffolds to help him make meaning of, make sense of the types of questions and how to interpret those questions, because that feedback goes beyond the learning. And him interpreting the questions will help solidify Jackson's understanding of the particular skills, concepts, and knowledge. So back-end scaffolds after the instruction, but lining us up for how things are moving forward. So let's talk about some of these very quickly in the chat box, and then we're going to wind down our time together. How have you seen scaffolds used in math talks in your own experience? If you would share that out, how do you see this being an important part of moving away from think, pair, stare to a true think, pair, share in your classroom? Use that chat box, share some ideas and thoughts. Anthony, thanks for getting us started by dissecting the prompt. What else? What have you noticed? Megan, favorite mistake. Yep. Chunking into smaller processes. Yep, good. Absolutely working together, peer tutoring. Students want to help one another. And, and Nancy McNally, that's an important part of this. They naturally want to help each other, but how often do we make our classrooms silent classrooms? And as Nancy said, peer scaffolding is often underutilized in the interest of control, and that can be scary. Absolutely.
I think one of the defining features of that is what Grant Wiggins and Jay McTighe would talk about. Our job is not to cover content, but to uncover content so that students can explore. And especially through that language, through the talk, through the different kinds of scaffolds that come all the way along, it allows us to uncover that content rather than simply just drone on and on to tell them, here are the things that you need to know.
Absolutely. And as we start to wind down, I want to ask this question. What do we do with scaffolds when we put them in place and they start to work? We've got to be ready to pull them away, right, Nancy? I mean, Nancy, I don't know, and maybe it's different in San Diego than it is in Waynesboro, Virginia, but when buildings are built here and they're finished, the scaffolding gets taken down. It doesn't get left up after the building's finished. Is that the way it is in San Diego?
Well, when I stroll through downtown San Diego, I sometimes question that. But yes, in theory, eventually the scaffolding should be dismantled.
And the same thing goes with math talks. If the hot dog, whether it's a sandwich, a taco, both or neither, we may not need that scaffold. In fact, we should not need that scaffold later in the year. Maybe after a while, sentence stems and sentence starters are no longer needed because we've pulled them back. One of the things we want to make sure we do is fade the scaffolds. If you would, in the chat box, type the word fade, F-A-D-E, put it in there. Because in addition to using scaffolds, we have to have a plan for removing them. We need to have a plan for pulling them back slowly, not too fast because it'll frustrate them, and not too slowly because they build a dependency. But we have to have a plan in place for fading the scaffold and to make sure that we're not using the same scaffolds in May that we were using in September. That's the other part of this. So while your math talks may need to be jump-started with a scaffold like the hot dog task, the goal is to build a community, a cohesive community that fosters a strong sense of belonging, that then encourages dialogue and discourse as part of normal operating procedure and not just something fun that we do on Fridays. It should be a natural part of our mathematics teaching and learning. And so with that, I'm going to pause and hand it back over to Kateri and the team. And Nancy, do you want to give any final words before we check on our success criteria?
Please, for those of us who are in elementary especially, to stop saying, I'm not a math person. We're all math people. We are all math people, regardless of whether some of the problems were a little bit more challenging for us. We're all math people.
Excellent.
Thank you, Nancy. Thank you. Yes. I was thinking about, before I jump into that statement, I was thinking about how many people noticed the hot dog conversation as a front-end scaffold. And I'm wondering, our emphasis there was about informal math language, right? Or non-math language, low risk. I'm wondering how often we allow kids to speak in their heritage language first, right? And then say, okay, now let's try to use some of this new math vocabulary and in English, right? And speaking first, whatever space is comfortable, can be a really powerful initial scaffold to make sure everyone knows they are math people. All right, let's check into our success criteria for a night. We were learning ways to engage learners in math talks. Hopefully you feel like, yeah. Can you explain the importance of math discourse for deep math understanding? Can you identify a variety of formats for Math Talks? When you get the recording, you can see all of our resources as well, but also just Google away and you'll find them all. Can I describe ways to scaffold speaking, listening, reading, writing in Math Talks, and some strategies for self-evaluation? So hopefully you got all of that and you feel like, yep, at least maybe a green, maybe a yellow. Like, yeah, I got some ideas, and now go try it out, guys.
And so, yeah, thank you again to all of our presenters. Thank you for everyone who joined us and participated today. And I hope you have a wonderful rest of your week.